All right, we are beginning our last unit of the year. It wasn't supposed to be the last unit, but this is all we're going to get to. So this is a Unit 9, Day 1. Now, Unit 9 is all about rational functions. Rational being any number that can be written as a fraction. So these functions have a division bar basically in them. A lot of them do. So kind of keep that in the back of your mind. Now, there's two kind of variations we're going to talk about: direct variation and inverse variation. The front side is all about direct variation. So direct variation, it'll look familiar. It's anytime you can write a function in the form y equals kx, where k is some constant. So k is any number, 5. Y equals 5x, that'd be a direct variation. Or y equals 1/2 x, that's direct variation. But for the most part, it is linear. So like over here are some graphs. I think my video froze. Over here are some graphs in this area. These are all examples of direct variation. And what it is, basically, the way I just kind of put it in very simple terms, is as x goes up, y goes up. A lot of things in real life kind of follow this pattern. If you're buying items from a store, the exact same item, the more items you buy, the higher your cost is going to be. Yeah, like I said, we can do a whole bunch of these kind of things. The more stones you put into the back of your truck, the more weight that's in it. So as x goes up, y goes up. But we say this proportionally. So as x goes up, y goes up proportionally, which is proportionally basically has to do with fractions. If one fraction equals another fraction, fractions being rational, that's why it's in this unit. Now the constant of variation, this k right here, you can solve it, if you notice, just by dividing x over. So the constant variation is going to equal y divided by x. So y is on top. That's one way of possibly making a mistake in this this first day or in this chapter is accidentally putting x on top, because it normally comes first. It comes first alphabetically, but y is on top on this one. So for each function, determine whether y varies directly. So does it have this special direct variation? Because you notice in the graph here, all these linear lines, those are direct variation, but if it doesn't cross at the origin, it's not direct variation. Okay, so it doesn't follow that right pattern. If it has a plus c on the end, then that's not direct variation. So you don't want anything else, no y-intercept added on the end. It has to go through the origin. That way, when x equals 0, y also equals 0. So for each function, determine whether it is. So the way to do that is to check all the y over x's to see if it's the same. It's the same constant, because it should be the same. It should say constant. That sounds silly. So when I take 4 divided by 2, is that the same thing as 8 divided by 4? The same thing as 32 divided by 16? Now, all of those, if you look, equal 2. So that is, yes, that is direct variation, because it stayed the same. The quotients were all the same. So it is yes, and then write the equation. Well, the equation is just plug in for k. So it would be y equals 2x. If you notice, y is always twice as big as x. So 2 to 4, 4 to 8, 16 to 32. That's direct variation. And if x doubles, y doubles with it. So we said as x goes up, y goes up proportionally. So it doubled. Here it went up by 8 from 2 to 4. Here it went up by 8 from 4 to 32. So you're multiplied by the same thing. Again, y divided by x. So y divided by x does 9 divided by 27. Does that equal 10 divided by 30, which equals 20 divided by 60? Is that true? 1/3, 1/3, 1/3. So it is true. And if it is true, then it's direct variation. So yes, that quotient, that constant quotient, is your k. So it'd be y equals 1/3 x. Okay. And the last guy here, y divided by x. So 22 divided by 11, does that equal 32 divided by 16? Yes. 2 to 1, 2 to 1. Does that equal 42 divided by 7? No. So that is not true. So that is not direct variation. So as x goes up, y goes up. Here, x went down, y kept going up. That's not direct variation. That's something else. Some other kind of variation we're not going to worry about this chapter. So here's just some different functions right now. Determine whether it's direct variation. So instead of giving you coordinates, we give you the equation. What we want to know is, can I make it look like this? So if I get y by itself, does it equal x times some number? So over here, if I divide both sides by 4, I'd get y equals 5/4 x. K is 5/4, so that is a yes. That is yes. And it says, if so, state what k is. K is 5/4, the number in front of x. It almost seems too easy. This guy, divide by 7, so we get y by itself, y equals 2x. Is it in that form, y equals kx? Yes, it is. It has a 2 right there. So yes, and k happens to equal 2. This guy over here, divide by 3, divide by 3, divide by 3. So I've got 3x plus 2. So is that in this form? If I can get both on the same page here. That's not. It has a plus 2 on the end. Okay, so that's not direct variation. Okay, and if you pick some ordered pairs of that, if x doubled, y would not double. It wouldn't be exactly double. It'd be pretty close to twice as big, but not quite. So that one is just a no. It's not direct variation. Number 3, write the equation of direct variation. So now we're going to give you some, if y equals 4 when x equals 3, so that's a coordinate, 3 comma 4, then what would y be when x equals 6? So it's almost like we gave you these tables up here. We said this was 3 and that's 4. What if x was 6? What would y be? That's what we're asking you to do here. So like we said, since k stays the same, they said it is direct variation. We know it is. That means every quotient should be the same. So every y divided by every x should equal the same thing. So one y over x should equal another y over x. So what if this y, which is 4 over 3, that should equal this y over that x. You see, here's a proportion. That's been a while. Think back to middle school when you had a proportion, which is when you have two fractions set equal to each other, and you want to solve it, it's set cross products equal. So I'm going to take 3 times y, set that equal to 4 times 6, and solve that guy. So divide by 3, I get 8. Y equals 8. So it kind of makes sense because 3, or x doubled from 3 to 6. So if x doubled, y should double. 4 to 8. Okay, so sometimes you could do it faster in your head, but not always. I would do it the way I showed you here. Okay, so here, like for instance, this one may not be as simple. So y is going to go from 10, and when it was 10, the x was -3, but it's going to go from 10 to -2. So I didn't subtract 12, I actually multiplied by something. I got to multiply x by the same thing. The fastest way to do it is separate proportion. Just make sure that y is over x. So 10 over -3. And then this in the y is -2 over x. So notice here we found y, here we're finding x. So our unknown is in a different spot. Just do the same thing, cross product. So -3 times -2 equals 6. That's going to equal 10x. And then divide both sides by 10. So x equals 3/5. Oh, I didn't write the equation. So I didn't write the equation yet. So oh, I skipped that part, didn't I? The equation here would be 4/3, so it would be y equals 4/3 x. Sorry, I skipped that step because 4 over 3 is k. And down here, you could say 10 over -3, so y equals -10/3 x. But then that's the second part. So I actually skipped the first part. Sorry about that. It's going a little too fast. So if they ask you to write the equation, make sure you do that. Example number 4. Each ordered pair is from a direct variation. So you don't have to check it. It just is. Find the constant of variation k. Well, k equals y over x. Probably getting tired of hearing that. So my y is 1/3 divided by my x, which is, 3. So just think, how did I do this? Think from middle school, how did I divide? Well, if that's 3 over 1, you can't really divide fractions, but you can flip and multiply. So multiply by the bottom's reciprocal. So I'm going to take this 1/3, and multiply by the reciprocal of 3 over 1, which is 1/3, so that'd be 1/9. Okay, so that's my k. So if I'm supposed to write the equation would be y equals 1/9 x. Okay. B, same idea. This is an ordered pair. My k is going to be y over x, which is going to be 2/5 divided by 5/7. I can't divide by 5/7, but I could take 2/5 times the reciprocal, 7/5, and I get 14/25. So my equation would be 14/25 x. Okay, and now if I gave you a new x, you can find the new y. All right, so that's direct variation. As x goes up, y goes up. Inverse variation is the opposite. Okay, the opposite because basically as x goes up, y goes down, but it's proportionally. Which basically means if x goes up and doubled, y is going to be cut in 1/2, or if x tripled, y is going to be 1/3. So it's proportionally going the opposite direction. And how we write this, it's y equals k over x. Instead of k times x, it's k over x. And the fastest way to find the constant variation would be to multiply x over. So x times y would equal k. So if they're asking for k, just take x times y. If they're asking for the equation, plug it into that first one. Okay. Determine whether the variation is inverse or direct. Okay, so what I'm going to do is I'm going to, remember, if it's direct variation, the quotients are all the same. So quotients are all the same. Here, the products will all be the same because I'll be multiplying. So on this first one here, I'm going to take 0.2 times 12, then take 0.6 times 4, take 1.2 times 2. If you notice, all these are 2.4. So that was pretty fast and easy. They are all the same. So the products are all the same. That means inverse. Okay. So this one is inverse. And the constant k is 2.4 equals k. Okay, so this guy here, let's try and multiply. Now if I take half of 1.5, that's 0.75. 2 times 6 is 12. That's not even close. And 6 times 18, so it's not direct. So now let's check the quotients. 1.5 divided by 5, that equals 3. 6 divided by 2, that equals 3. 18 over 6, that equals 3. 18 over 6. So if the quotients are all the same, this is direct. And this would be y equal, I'm sorry, they just want k, don't they? So k is 3. And the last guy here, again, check the products. 1 times 2 is 2. 2 times 1 is, well, that's 2. But then 3 times a half, that's not 2. So it's not inverse. Now let's check direct. So 2 divided by 1 is 2. 1 divided by 2 is a half. That's not it either. So this one's actually neither. This one didn't meet either of those criteria. Example 6. Each ordered pair is from an inverse. We know it's inverse. Find the constant variation. Remember, the constant variation, if it's inverse, is x times y. So this one's going to be 2 times 5 or 10. This would be 2.5 times 28, and that's 7. So that one's almost too easy to find the k. Now to write the equation, y equals 10 over x. Because now you're just plugging it in for k. Okay. And then down here, y equals 7 over x. So there's my equation. If I want to find more points, I could plug the x or the y and I could find it. So that's what we're going to do down below here. Suppose x and y do vary inversely, and x equals 7 when y equals 4. So kind of think of this, it's the same thing as this information right here. So what is my k? My k is going to be 7 times 4, which is 28. That means my equation, so write the function, would be y equals 28 over x. That's my first answer. Then find y when x is 14. Well, that's 2. Okay, I just plugged 14 in. Plugged 14 in for x and got my answer. Okay, down here, suppose x and y vary inversely. Again, inversely, so if I want to find k, take -5 times 15. That gives me a -75, so y equals -75 over x. Now find x when y is 3. So if I'm solving this guy, and probably I think the easiest way of doing this, let's use our proportion idea. If I put over 1, now I've got fractions that equal to each other. So cross products 3 times x equals 1 times negative 75, and then divided by 3. So this would be x equals negative 25. Okay, so hopefully this helps. Hopefully if you got any questions, let me know. I went pretty fast. Pause anytime you need.